Let's see integrated rate equation, and in this context let's study about integrated rate equation for zero order reaction. So what is a zero order reaction? A reaction is zero order if its rate is independent of the concentration of reactants. That means if a reaction is taking place, let's see, R is getting converted into P, and in this type of reaction the rate of reaction is proportional to 0 power of the concentration of the reactant. That means the concentration of reactant doesn't have any influence on the rate of the reaction. So it can be written as this. For this reaction, the rate equation can be written as rate is equal to, reactant concentration is decreasing, so negative concentration of R and dt. This will be the rate equation, and in that case if we take rate constant also, so this equation would become small k and then the concentration of reactant. Now the concentration of reactant has no influence on the rate of the reaction, so it will be written as 0. And we all know if any quantity has raised to power 0, then its value is unity. So this equation can be rewritten as rate is equal to, again the same terms, is equal to, this is going to be 1. So we can again rewrite it by multiplying both sides with -1. We will get and moving this value, taking this value to the other side, we will get now this is, we have next equation, we have moved dt to the other side. Now let's see what is going to happen if we integrate the equation. So this is going to become, this value changes to concentration of R is equal to minus K, then we have T and a constant also known as rate constant, or sorry, also known as integration constant. So now this, we have equation 1, this last one. So now I'm rewriting this equation once again. Let's see. This is what we obtained right now. Equation 1. So again, if the reaction is at initially taken, then in that case time will be 0, and the concentration would be in that case equal to initial concentration. The reaction hasn't started yet. T is equal to 0 and initial concentration is R0. Now let's put these values over here in the equation number 1 we have just written over. So in that case we have to place T value of T over here, and this whole value will turn out to be 0. So this will be R equal to, and then we have minus K into 0, T is equal to 0, plus constant, integration constant. So this value will be equal to I. This overall turns out to be 0. So this value can be placed, sorry, one more thing, let's put this value over here. This is for initial reaction, initial rate of reaction. So now this R0I can be placed over here, and so in that case it will become, putting the value in equation 1, R is equal to minus K T and then plus it becomes like this. So now we can move certain values. Let's take it to the other side. It will become plus KT, and move it to the other side, and then it will become minus concentration of reactant at time T. Now let's do it again, is equal to, and this becomes R. So we have this value. We can take T also to the other side if required. Now this is, let's take it to the other side. What will happen? It will be like this, and then we have these concentration terms. This is how we are going to get the desired result for zero order reaction, integrated rate equation for zero order reaction. Now this is going to show one thing to us, that initial concentration minus concentration at time T will be written like this. Now if a graph is plotted in this situation between concentration at time T and time T, we are going to get, according to this type of graph, because the value, the initial concentration is being subtracted by final concentration. So at time T interval the value of concentration will keep on decreasing as the time is increasing.